Hi everyone, today we're going to talk about exponential growth and decay. And if you look at the very top, this is in exponential functions. So we're going to use basically, if you look at the same equation that you used for an exponential function, and this one is a tiny bit different, and I want to explain why. So these problems today are going to talk about growth, like a percentage maybe. And in that case, if something grows at, let's say, 50%, you also get your original money back. So if you invested $100 and they, said in a year you'll have 50% more, then you would have $150. So if it's growing, we have to just change that rate to add the one back so you get your original back as well. All right, so these first few problems, we're going to talk about growth. All right, and I'm just going to give you a lot of examples. We have Hillsville, and it tells you the growth rate of Hillsville is 15%. Currently, they have 5,000 people, and how many will they have in 5 years? Okay, so I'm going to go ahead and write f of x equals a 1 plus r x. So when I look here, remember A stands for the initial amount. Well, the initial amount of people in Hillsville is 5,000. So I'm going to put 5,000. The rate at which it's growing is 15%. Well, 15% is 0.15, but I also get that 5,000 people back. So my rate, I'm going to fill in here 1.15. And I'm going to raise that to the x power. So this is kind of like function notation, and now I'm going to solve it for 5 years. Okay, so we're going to say f of 5. So this is me plugging in 5 because I want to find out in 5 years how many people I would have. So, all right, so with my calculator, I'm going to put 1.15. I have to put this rate in first. Do not multiply that first because the only thing being raised to the 5th power is this 1.15. Okay, so that raised to the 5th power plus 5,000. I'm going to double check. That does not seem right. Let's see what I did wrong here. 1.15 raised to the 5th power. Hold on, sorry you guys. Here we go, now we're right. 1.15 raised to the 5th power times 5,000. There we go, I think I was adding. So f of 5 equals 10,050, let's just round it to 57. Okay, so in 5 years, the population, this will be the new population. All right? Okay, let's look at Valleytown. All right, so Valleytown, the growth is 1,000 people per year. The growth is 1,000 people per year. So now it's going up by a certain amount of people every year. Notice that does not say a percentage. It starts off with 500 people. Okay, so this to me, since it's going up by 1,000, up by 1,000, up by 1,000, that is a linear function. This was going up by 1%. So I'm thinking y equals mx plus b, or f of x equals, even if you think about it like this, mx plus b. So f of x equals, what was the original amount? 5,000. And then it was going up by 1,000 every year. Okay? So if we wanted to figure out how many people would be there after 5 years, we would plug in, I know I didn't say that in the problem, but what the heck? So now we have 1,000 times 5 plus 5,000, oops, yep, equals 10,000. So that almost is very similar. Usually it's going to be way different with exponential growth. Okay, but look at the percentage. That was just increasing by 15%, and this was increasing by 1,000. Okay, so the next example I want to talk about is compound interest. And compound interest gets a little tricky. I have another video on there for you to watch, which is old school, but it is great, really showing you how to, what compound interest is all about. But here's the equation. So I know you've already watched that. I just kind of want to run through this with you. The formula is A equals P, and then usually it's principal times rate times time, but since it's being compounded, this is the equation right here. The A stands for the amount that you're basically getting back. Let's pretend you're investing money. The A stands for the amount of money you would get back. The P stands for the principal, so that's the amount you're investing. This is just a 1. The R stands for the rate. The N is for the number of times it's being compounded. So basically, let's say you have an account and I tell you it's being compounded yearly. You would put a 1 in there because it's how many times a year. If I say it's being compounded 4 times, it means they're going to recalculate everything 4 times during that year. All right, and then T is time in years. Okay, so we're going to do some problems because I know that's a little bit confusing. All right. So this first problem says I'm going to invest in a CD. All right, I'm going to deposit $3,000. I have an annual interest rate of 8%. And this does not tell me how many times it's compounded. That just says it's an annual rate. That's the rate I'm going to use. Okay, it says it's compounded quarterly. So basically 4 times throughout the year, you know, after 3 months, they're going to reevaluate. They're going to, figure out how much I've gained and recalculate the whole thing. So, but we can just use this formula to see what our final product is going to be after 5 years, okay? So A is the amount that I'm going to get back. This is what I'm looking for in this problem. Principal is the amount I deposited. 1 plus the rate. The rate is 8%, 0.08. N is the number of times it's being compounded. Well, it's being compounded quarterly, so I'm going to put a 4. The N is also up here as an exponent. And then time in years, 5 years. Okay, so now keep going along here. Now I'm just solving everything algebraically. I'm going to do all of this. 1 plus 0.08 divided by 4. That gets me 0.02. I know you would do some of these steps, more than one at a time, but just for me to show you how to do this. 1 plus that is 1.02, and then 4 times 5 is 20. Okay, so now in my calculator, I have my 1.02. I'm going to raise it to the 20th power and multiply it by 3,000. And I'm going to end up 4.84. I'll just round it to the nearest cent. Okay? So we're going to compare these. This is saying I had $3,000 and that's the same percentage, and then it was compounded quarterly, and that's how much I have after 5 years. So if you look at this problem down here, it's very similar, but let's talk about what's different about it. So we start with the same amount of money. The annual interest rate is the same, it's still 8%. This one was compounded quarterly, which means 4 times they reevaluated, and this one is compounded once a year. Okay, so we're gonna try to see which one is better, and I wanna know how much money I have in 5 years. Okay, so keep the A the same, the principal is still the same. 1 plus the rate is still the same. This is where it gets a little different. How many times is it compounded? Well, the other one was compounded 4 times. This is compounded once. Okay, and then it's 1 times 5 because that was how many years we have the money invested for. Okay, so if I look here, A equals 3,000. Let's spiffy up in here. I know that 0.08 divided by 1 is 0.08. Adding that, so I have 1.08 raised 1 times 5 is 5. Okay, so now I take my calculator. 1.08 raised to the 5th power times 3,000. So now if I compare those prices, now this one I get pretty close, $4,457. So this one I have $50 more coming back to me. And you can see that was a very short loan. That was a loan for only 5 years. So it wasn't, it wasn't a lot of time, and it's already $50 difference, and I haven't done anything. Everything else was the same except for the amount of times that it was compounded. Okay. So the next thing I want to show you is what about if it's decaying? So we hope our money is in, invested and going up, but sometimes we have exponential decay. All right, and that just means it's going down. So once again, if you look here at exponential decay, all right, notice the same basic formula. It's still an exponential formula, but if you look now, it's decreasing. And so this can be a little confusing. So let's act like it is money and the money's going down. If I had $100, then I said it's going down by 15%. How much percent do you still have? That's why we're subtracting here. 1 minus 15 would be 85. So you'd be saying you have 85% of it still. So if the money is going down, if it's decaying, that's how that is going to look. All right. Here's an example. Let's pretend I tell you that there's a video, maybe one of my videos. Just joking. I'm sure people aren't lining up to see that. Okay, so I have 1,000 views per day. Oh, you need 1,000 views per day to be a fan favorite. All right, so I produce a video and I'm going to be on this fan favorite list if I get 5,000 views a day. All right, Amy's video currently has 8,192 views. So it means right now she's a fan favorite, and it's going to decrease at 25%. And I think the question must have said, when does she stop being a fan favorite? Okay, so I can look at this chart, or we can write the equation. Let's start off with the equation. Okay, so f of x equals a1 minus rx. Okay. So A is the original amount that I have, 1 minus the rate. The rate is 25%. To the x power. Okay. Okay, 1 minus 0.25 is going to be 0.75. So here is my basic equation. All right. Now, if you're just filling out a chart, I mean, you can just say, well, 8192 multiplied by, what is the percentage I have? 75%. And I should get 6144. Now let's just make sure that was right in here. So if I plug a 1 in here, well, that's going to be that. So now that's going to work out because that's what we did. So now if I plug a 2 into this equation, we have 0.75 raised to the second power times 8192, and that gets me 4,000. All right, notice I keep coming back to my original equation to get the next one. Now, if I just wanted to keep going, I would be saying, I would multiply this by 75% and I would get this, then multiply this by 75% and I would get this, multiply this by 75%. Or you can keep plugging it back in here if I want to multiply this by 0.75. I would keep getting the same number, okay? Or we can try it again. Let's plug in 4 and see if it works. 8192, oops, sorry, I got to do my 0.75 first. Raise, we'll practice with the 3 and make sure we got the same answer. Times 8192. Yep. Okay, 0.75 raised to the 4th power times 8192. So you can see the video event. So if the question asks when is it going to stop, well, I'd have to keep going because on my chart, I'm still a fan favorite, but I'm getting closer here. Or we can just try. Let's try 6 and see what would happen with 6. If I did 0.75 raised to the 6th power times. Oh, I can see it's 6. I am still a fan favorite. Okay. Well, maybe let's try 8. Let's see if at 8, I'm still a fan favorite. Now I'm not a fan favorite anymore. At 8, I am not a fan favorite. And we might need to actually go back and check 7 because I'm not sure if 7, which way 7's going to go. So I'm going to plug 7 in. And 7, I am still a fan favorite. So once I hit 8 days, I am no longer a fan favorite. Okay? All right, so that's basically exponential decay when the number is getting smaller and smaller and smaller. And then growth is when it is obviously getting larger. All right, have a good day.